Oh, good day. I will be talking about the graphical method of structural analysis. Now, this particular method was brought in by Maxwell, and the process involves using graphical methods to resolve forces along joints in members and structural members. Now, the procedure is very simple. We first solve for the reaction at the support using equation of equilibrium, then moving clockwise around the outside of the truss, we draw to scale the first polygon for the entire truss. Then we take each joint in turn. We draw the first polygon by treating successful joints acted upon by only two unknown forces. Now, we measure the magnitude of the force in each member from the Maxwell diagram. Then we note that work proceeds from one end of the truss to the other end. Now let us look at this particular member here, this particular example. Now, supposing we have this truss member, we need to use graphical method to solve it. Now, the first thing is that we have to calculate the step one is to solve for the reaction at the support by solving equation of equilibrium for the entire truss. How do we go about that? We have 200 kilonewtons coming down, 200 kilonewtons coming down, and we have this force. So to solve that, we just take moment about this point to get this reaction. We can take moment about this point to get this reaction. So, but since there's only one unknown here, we take moment about this point to get this reaction. Now, summation of moment about point 1 to be equals to 0, and we are adopting this sign convention that clockwise is positive. Now, if you want to do that, let's start 200 moving to this particular point. 200 times 3 plus 200 times 3 plus 3, 6. Then, because these ones, they are in positive direction, but this one is coming in this direction to this place, so minus r2 times 3 plus 3 plus 3 plus 3, 12 equals to 0. By the time we resolve it, our r2 will be equals to 150. Then to get our vertical component, we can say summation of forces along y-axis to be equals to 0. So all forces coming up or down, we sum them together. So starting from this, we have r1 going up, we take this one to be positive. This one coming down, we have negative 200, negative 200. Then this one going up again, positive. We sum it together. That gives us our r1, which is 250 kilonewton. Now, the next thing is we want to look at the forces along the s component. But since there's no other force, summation of forces along this s is equals to 0. So it's only h1 we have, so it is 0. I mean there's an external force, maybe 1 kilonewton, then that one will be equal to this h1. So the next thing is that we move clockwise around the truss and space between the force and members are lettered. What am I trying to say is that we label all the letters, we label letters in between all the members. Then let's say we are taking this as point A, this side as point A, from this support to this support, the whole place here as point A. Then the next one is we have a support, we have point B, we have another one, point C, we have another one, we have point D, like that. Then in between we label them. If we have E here, we have F, G, H, I, J, K, L. Now, space between reactions R1 to 250, R1 is 250 and R2 is 150. This is R1, this is R2. The space between them is labeled as this R1, this R2. The space between them, as I said the other time, this is labeled A. Now, space between reaction R2 and B and load, this load 200 is labeled as B, and so forth, like that. Now, the next thing is that we take each turn in joint, we draw a polygon force by treating successive joints acted upon by only two unknown forces. Now, moving clockwise around the truss from space A to space B. To get to B, we find how many forces there. This is the only force, 150. So this 150 going upward, we draw it upward. We draw it upward like this. A to B, we draw it upward. A to B, right, like this. Then we come back again. But before we start drawing upward, we must choose a suitable scale. In this case, we are using 10 kilonewton to mean 1 millimeter. The same thing applicable, you have to take a scale. Now, therefore, we translate it that the force 150 kilonewton from A to B will be equal to 15 millimeter, like that. So using the same procedure we did for other external load. So for A to B, let's take A to B. A to B is just this force that is there in between. It's 150, so we take it AB to be 15 millimeter. Now from B to C is 200, B to C is 200, but you see pointing upward or down, it's pointing downward. We draw 20, that's 20 millimeter. If you convert it based on our scale, 20 millimeter downward. Then we come again, C to D is pointing downward again. C to D 200, we draw 20 centimeter downward. Then we come again from D to A, we have 250 going upward. D to A, we have 250 going upward. Now, having done that for the external loading or for the major forces, then now we now take into consideration the member forces now. Now, the member forces is what we are going to treat now. We begin to find the member forces, that is, DE is a horizontal member. So we draw DE horizontally. DE is this from here. We draw it horizontally. So, and it's starting from this particular point here. What's it called? DE. We draw it horizontally. We just draw horizontal force here. Now, the next thing is AE, which is a vertical force. We draw AE vertically. AE, we draw it vertically. Then the DE and AE, we intersect. Oh, how can I have this diagram together? Oh, let me see. AE and DE, they are acting. AE and EE, we intersect at point E, and EF is at 45 degree. EF is 45 degree. We draw EF at 45 degree. Let's look at it here. EF 45 degree. We just draw it to wherever it's touching AF. Wherever it's touching AF, we just draw this at 45 degree. Now it's going to touch a point at AF where we have drawn our horizontal distance. So where we draw this one, wherever they meet, that's the point. So FG, this is FG, is just down from F, we draw it. FG is vertical, drawn from FG. F and G, this is downward, we draw it. Now let's take example G to H is at 45 degree also, we draw it. The same thing, we do it for every member. Then at the end of the day, we will now start measuring each one of them. The distance from here to here, we measure each one. Then till we come to the based on the unit that we have applied. So if since we said 10 kilonewton is equals to 1 millimeter, so if we have 15 millimeter now, that will be like 150 kilonewton. So the same, that's how we're going to draw it, and then we come up with our drawing. So at the end of the day, you just put your member forces, you write everything down. Now these are all the members. It is always good to do it on a, let me say, using graph sheet, which I will still think of how we are going to try to do to make it easier, or if I can get a graph book. But